In this video, we're going to continue our notes on section 2.5 and look at our next example. So now we want to find the derivative of this function f of x. So again, I'll encourage you to pause the video here and work out the derivative on your own, and then we'll work through it together. So one thing you'll notice about this function is that it involves square roots, and it also involves terms with powers in the denominator. So we haven't seen this explicitly in our basic derivative rules, but is there a way that we can maybe change some of these terms in our function so that they look like these functions that we've already looked at in our basic rules? Heck yes, you say. Well, we can change those square roots and those exponents so that all of our terms are just bases with t with either fractional exponents or negative exponents. So let's first rewrite our function in a way that we can compute the derivative using the basic rules that we've already seen. So now f of x, so I'm not taking a derivative yet, I'm just rewriting f of x, my function, is equal to, well, I have 3 times square root of t is the same thing as t to the positive 1/2 minus 4 times t, if I want to bring that t to the 4th in the denominator into the numerator, that 4 changes to a negative 4. So I can rewrite here. So I just have a power function, and then plus 5 times e to the t, which we've seen in our basic rules how to compute the derivative of. All right, so now that we've rewritten our function, we recognize that each term in our function, well, we have just a sum or difference of terms, each of which is just a constant multiple of one of the power functions that we've seen before. So let's get started computing the derivative. So computing f prime of x, well, we have, and we can, rather than going out in complete detail from, as in the previous video, we can just kind of speed things up a little bit, knowing that if we have a derivative of a constant times our function, we just get that constant times the derivative of that function. So now we just need to compute the derivative of t to the 1/2. So using the power rule, we get 1/2 dropping down. So 3 times 1/2 times t to the 1/2 minus 1 minus 4 times negative 4. Again, that power comes down, times t to the negative 4 minus 1 plus 5 times e to the t. Recall the derivative of e to the t is just e to the t. So now we can clean this up a little bit and write this as 3 over 2 t to the negative 1/2 minus, so we have 4 times negative 4 becomes a negative 16. So we get negative 16 or positive 16 t to the negative 5 plus 5 e to the t. And then typically at this point, we want to rewrite our derivative that we just found, or that derivative function, without negative or fractional exponents. So kind of convert it back to the form that we already saw it in. So this would become 3 over 2 root t. Recall that if we have a negative exponent, in order to make that negative exponent a positive, we need to bring that term to the denominator or to the numerator, whichever side it's currently on. We want to bring it to the opposite side. So that's why we bring that t to the denominator and then use that square root as the 1/2 exponent. Then now we add 16 in order to make this negative 5 a positive exponent. We bring it to the denominator. So then denominator of t to the 5 and then times 5 e to the t. So our derivative f prime of x is equal to the following function.